And I'm going to go and make a conceptual mass. And let's make the one-room house. One-room schoolhouse, whatever you want to call it. So I'm in my massing editor. And I'll make a couple of new planes. Create the dimensions. And I'm going to call this one length. Careful with my spelling. Be a type or an instance? Type or instance? I don't know. Let's make it a type. And I'll make this width. Make it a type. And if I want to enforce the length and width to be the same, I can do that by going here. And I can make the length equal the width. Spell it right. So now they're the same value. And if I change this to something a little more reasonable for a one-room house, they both change. And I've got that little square there. And I can go and draw a little rectangle. Now you see it's not, doesn't look like a rectangle. That's because it's on the wrong plane. So if I go back and set my drawing plane to be the bottom again and show so I can see my drawing plane, then when I draw a rectangle, it looks like it's on the right plane. It is on the right plane. So I can, once again, lock it to these reference planes. And if I want to change the size, I change the size just to test it to make sure it's working right. Looks good. And then I can click that and extrude it. Now I'm going to go ahead and change the, I'm going to lock the profiles, and I'm going to make this, use this to control the height of it. Call this the eave height. And just to test it, I can change the value. And it works. So I've got the start of this one-room house going pretty well. And I could load this into the project. And place this one-room house. And you'll see that the parameters showed up over here before when they were instance parameters. But now if I want to change them, I have to go into edit type, and I can change them here. So let's make it 9 feet tall. Let's see what happens. Anything actually. 16 feet square. some reason. Typical kind of process is to check it and make sure it works and all that. You can also lock these planes to reference planes. That looks better. All right, so we've made this simple cube. I did not put a roof on it because Revit has really good tools for putting a roof on. You know, so I'll just go ahead and put walls on just to play around with that a little bit. Do wall by face. And I can put a roof on. Whoops. Cancel that command. And go to roof by face. And it finds that face. Don't think I did it yet. So roof by face will just put a flat roof, I believe. Yeah. Now I can click on that, however. Yeah. I can also put a roof on by footprint. And this has these little icons for slopes. So I can pick on that and say, does not define a slope. And that does not define a slope. And that will give me a gable. So now I've got my one room house. I could create another mass or you know, to define a chimney, but I'm not going to go through that right now.
So did you use the roof command to create like the second floor basically? Because I see there's like the flat roof and then the tall roof. Or the gabled roof.
Yeah, so there's basically an attic up here.
Okay.
Now, you'll see the wall goes all the way up to the upper roof, which was just a default choice in Revit. So you don't, it doesn't have to go up, but you can make it go up. That's called attaching the wall. If I detach the wall, I can change that behavior. Okay, so my point here is to show you one way of doing it. Now, that's, it's a good way, and it allows you to model it in certain ways. So let's see what happens if I pick that mass and change the type values of it. I don't know what's going to happen. So this is experiment. So I can update it, and I wonder if that one will that one won't update though. I can pick my my walls, and I'm going to right click here and select all instances and update them all at once. And it looks like that actually changed the roof, but the roof is still higher than I maybe wanted it to be. So just sort of realizing that how you build the model determines how you can change the model. Now, I want to show another way to think about this one-room schoolhouse. And so I've got 3 lines there, 3 reference planes. And I'm going to create a aligned, let's get to my right plane. So that's my drawing plane, show, so I can see it. And I'll create an aligned dimension here, from here to here, a string of dimensions from here across. And you'll notice there's an equal marker. I click on EQ, then it creates this as a center line, and they're equally divided. So if I were to change this, it always stays equal there. And I could make this into my dimension. I'll make it an instance this time. And so those two reference planes should move when I change that dimension. Yeah. Now, I'm going to go to this. I'm actually going to go to the east elevation. And I see these pieces. And I'm going to control click and drag this up to give me another height. And I could do another height. And why don't we name these things properly? So I'm going to call this the ridge, and this the eave. And and I'll put a dimension here, a dimension here, and call it Eve. All right, now, so I basically described the elevation of this house. And if I create a line now, like that, I'm probably going to have to align a bunch of things. I don't know what's going to happen here. That's kind of right. I'll lock the profiles here. So, now I've got this little shape, and I test it. This is called flexing the model. I flex the model to see that it works, see if it works. No, doesn't work. So let's cancel, undo, and go back. Yeah, I need to lock those edges. Another good tip here, just to know, figure out. I can set the center of rotation, and then when I orbit, it goes around that object. It's a little easier to handle. Go back to my setting those. So my offsets are here, and I can change those too. I can change the ridge heights. So, so I've got to dig into that and make sure that things are locked properly. That's kind of fun. So that's a good example of an unexpected behavior, which can be an interesting design result. I should be able to control that, though, if I want it to stay symmetrical, by locking these points And that's more what I intended. So I've got a parameter that controls the ridge height, another parameter that controls the eave height, so I can control the slope of the house, slope of the roof. Now these are instances, so they show up over here. And it's got drag arrows, allow me to drag it around some. And I can change the length with parameters.
On that second one right there, is there a way that could you invert that with your current parameters? Like, could you make it like a downward V instead of an upward?
Make the ridge low?
Yes.
Probably. So I've just changed the ridge height to be below the eave, right? So that's a great idea. And that's a great example of how, you know, the way you parameterize it can have such a big effect on what you can do with the form. And if we go back to family again, and I'm going to save it. And parameterize it a different way. So if I get rid of that parameter or that dimension and put dimension here and make that one eave, ridge, whoops. Then this one, you know, as long as it's a positive value, it's not going to go up. And I don't think you can put a negative value in. So let's try it though. So -2. Yeah. So you cannot put a negative value of a dimension in. Dimensions can only be positive. So so this one is controlled to always have a gable, while this one can have either a gable or a butterfly roof. Now, probably my experience that they probably cannot be 0. 0 worked, okay. And this one, if it were 12 feet, it would be flat also, yeah. They both worked as flat roofs as well. So, you know, this is really what I'm trying to get at is the way you decide to parameterize it determines what kind of shapes you can make. And that's why in the assignment, I want you to parameterize it multiple ways. You know, yet another way to do this particular one would be this one-room schoolhouse. is we could make a conceptual mass. And I'm not going to go through all this, but just to point out what else you can do is we could make the rectangle and then go to the side here and set this as my drawing plane. And then draw a line on that plane like that and create a form. So and I kind of messed that up, but so I didn't drag it perfectly evenly. But you see, so we could conceive this house as not being a single volume, but being 2 volumes, and that means that we could do things like make that overhang, or maybe even make the eaves overhang with parameters. So there are different shapes we can make. Create a veranda on the one-room schoolhouse with that. And we also have a irregular slope. So there's a ridge here, but this slope is steeper than this slope. And you could play with those variations on the one-room schoolhouse. Now, as I kind of mentioned, the saddlebag house and the dog trot house are basically 2 one-room houses composed together. One of them just abutting each other, and one with the passageway in between. So once you start with this one-room house, you could create a new family, new conceptual mass, I mean. And we could go back to my one room and I could load it into this new family. And put 2 instances there, and start to make the the saddlebag or the dog trot out of the masses that I've already created. And this is really weird. The next thing I'm going to show you. I know I've given you so much already that this one's probably not going to make sense, but let's do it anyway. So I could create a new parameter here, and so I created the room length there, and I can control that. Didn't quite do it. Yeah. Because my room length was 0, it couldn't make a 0 length element. So if I make that 10 feet, and maybe it'll work this time. Yeah, kind of did. And, so I'm using the parameters of this family to control the parameter value of a component family. And that's called a nested family because it's, it's like those Russian dolls with one doll nested inside another doll and on. So you've got, the one room family is nested inside of the dog trot family. And I can control the dimensions of the one room family by the dimensions of the dog trot family. And the notion of building up, trying to identify what the smallest component is, and then building up a library of families and nested families out of the same kind of component is where you start to create your own language of architecture.